of SA-1. Here is the direct integration method. This is A, this is small x, this is L minus small x, this is W, x is equal to 0, this is L, this is x is equal to L. Maximum slope and deflection on a cantilever beam subjected to point load at the free end. dy dx is equal to 0, dy dx not equal to 0, y is equal to 0, y not equal to 0. M by I is equal to F by y is equal to E by R, implies M by EI is equal to 1 by R. M is equal to EI into d square y over dx square. Mx is equal to W into L minus x, where mx is equal to implies EI over d square y by dx square is equal to W into L minus x, which implies EI into d by dx dy by dx is equal to W into L minus x, which implies EI integration d into dy by dx is equal to W integration W L minus x into dx, which implies EI into dy by dx is equal to W into L into x minus x square by 2L plus constant 1. Constant 1 is equal to 0. Therefore, at x is equal to 0, at x is equal to 0, constant 1 is equal to 0. If at x is equal to 0, maybe the velocity or dy by dx is equal to 0. Therefore, constant 1 is equal to 0. Then again integrating EI into dy into WLX square by 2 minus WX cube by 6 plus constant 2. If constant 2 is equal to 0, when x is equal to 0, comma y is equal to 0, then dy by dx is equal to WL square by 2 EI, which implies y is equal to WL cube by 3 EI. W naught x is to 3 by 2. Note that this answer is for cantilever beam with a weight W at its end, free end. If for a cantilever beam a uniform distributed load is there, then this is x, this is L minus x, this is W per meter, this is length L, this is x equal to 0, this is x is equal to capital L, mx is equal to W by 2 into L minus x whole square. Therefore, dy by dx is equal to WL cube by 6 EI, y is equal to WL raised to 4 by 8 EI into d square y by dx square is equal to W by 2 into L minus x whole square. Since mx is equal to EI over d square y by dx square, where 1 by r is equal to d square y by dx square, then see here, this is force, this is weight W, this is L minus a, this is a, then this is a, this is a, this is b, this is L d theta by ds, this is y at a, dy by dx at a is equal to W a square by 2 EI, semicolon y at a is equal to W a cube by 3 EI, dy by dx at b is equal to W a square by 2 EI, y is equal, y at b is equal to W a cube by 3 EI plus L minus a W a cube by 2 EI. Hey, see here, this is a, this is L minus a, this is W, this is L d theta by dx, this is a, this is y at a, this is dy by dx at a, which is equal to W a square by 2 EI, maybe from this dy by dx. Okay, then y at a is equal to WA cube by 3i maybe from this. Okay, then dy by dx at B is equal to WA square by 2EI from this since WL square by 2EI from this y is equal to WL square by 2EI, then y at B is equal to WA cube by 3EI plus L minus A into WA cube by 2EI. This is A, this is L minus A, this is L, this is curve, this is y is equal to WA ratio of 4 by 8EI, this, then this one is curve, then this is y1, this is y is equal to WA ratio of 4 over 8EI, then this is y1 is equal to WA ratio of 4 by 8EI plus L minus A into WA cube plus L minus A into WA cube by 6EI. Then y1 is equal to WA ratio of 4 over 8EI plus L minus A into WA cube by 6EI. Then y is equal to WA ratio of 4, y1 is equal to L minus A into WA cube by 6EI, dy by dx is equal to WA cube by 6EI. Then y is equal to WA ratio of 4 by 8EI plus y1. This is y1. This can be the y or y1. Y is equal to W ratio of 4, A ratio of 4 by 8EI plus L minus A into WA cube by 6EI. Find out the maximum slope and deflection of a simply spotted subjected to control point load. This is L by 2, this is L by 2, this is A, C, W, B, this is W by 2, this is W by 2. Mx is equal to W by 2 into X, EI into D square Y by dx square is equal to Mx, EI into D square Y by dx square is equal to W by 2 into X, EI into dy by dx is equal to W x square by 4 plus constant 1, x is equal to L by 2, then dy by dx is equal to 0, C1 is equal to minus WL square by 16, at x is equal to L by 2, dy by dx is equal to 0, C1 then C1 is equal to minus WL square by 16, putting the value EI into dy dx is equal to Wx square by 4 minus WL square by 16, which implies EI into EIY is equal to Wx cube by 12 minus WL square x by 16 plus constant 2. When x is 0, y is equal to 0, then constant 2 is equal to 0, then y is equal to Wx, maybe Wx by EI into x square by 3 minus L square by 4 at x is equal to L by 2, y is equal to WL cube by 48 EI, dy by dx is equal to 0. If x is equal to 0, then dy by dx is equal to WL square by 16 EI. Then this is at L by 2, this is A, this is C, this is B, this is W per meter. Then mx is equal to WLx by 2 minus Wx square by 2 EI into D square Y by dx square is equal to mx, EI into dy by dx is equal to WLx square by 4 minus W by 6 x cube by constant 1. At L by 2 minimum slope, which implies dy by dx is equal to 0, then 0 is equal to WL by 4 L by 2 whole square minus W by 6 L by 2 cube plus constant 1, which implies constant 1 is equal to minus WL cube by 24. Then EI into dy by dx is equal to WLx square by 4 minus Wx cube by 6 minus WL cube by 24. Then this is L minus A, this is A, this is W per meter, this is length, this is curve, this is straight line. If W per unit meter is equal to 1 km per meter, E is equal to 2 into 10 raised to 5 Pascal and I is equal to 1 into 10 raised to 9 millimeter raised to 4 Here C here, this is A, this is C, this is D, this is W, this is W, this is W, this is A, L, then here A, this is W, this is W, this is E, this is D, B, this is A, this is A, this is L, then A, C, D, B, W, A, W, A, this is M by EI loading, this is WA into L minus A by 2, this is WA into L minus A by 2, slope and is at any section given beam, is shear force at corresponding conjugate beam, shear force at corresponding point of conjugate beam, shear force A at C is equal to 0, shear force A at R is equal to WA into L minus A divided by 2, shear force C at left side is equal to W plus WA into L minus A by 2, shear force at right C is equal to WA into L minus A by 2 minus WA, which is equal to WA by 2 into L minus A minus 2. Then here shear force at right of this C is equal to plus WA into L minus A by 2 minus WA, which is equal to WA by 2 into L minus A minus 2. Shear force at D left is equal to WA by 2 into L minus A minus 2. Shear force at right D is equal to WA by 2 into L minus A minus WA into L minus 2A. Shear force at right of D then shear force at critical point of B is equal to WA L minus A minus 4 minus half into A into WA, which is equal to WA by 2 into L minus A. What is this half A into WA? This can be the area of this triangle. This can be, for example, this can be here the weight is towards here. See here, this is EI, this is 2EI, this is L by 2, this is L by 2, this is W per unit meter, this is M by EI loading, then this is M by EI, this is WL by 4, this is WL by 8, then this is M by EI loading, this is 2EI, this is EI, this is L, this is 2EI, this is EI, this is L, this is WL square by 16EI, this is WL square by 8EI, this is W 3WL by 8, this is WL by 8, this is L by 2, this is L, this is M by EI, this is M by 2EI. Summation MB is equal to 0, which implies R into L minus half into WL by 4 into L by 8 plus L by 8 minus half into L by 2 into WL by 8 into 2 by 3 into L by 2, which is equal to 0. Then what is this? R into L. This can be the reaction which can be upward. Then minus half into WL by 4 into L by 8 plus L by 8. Then which implies R is equal to 5WL by 46. RB is equal to WL by 24. Shear force C is equal to 5WL by 46 minus half into L by 2 into WL by 4. Then shear force at C is equal to 5WL square by 96 minus half into L by 4 into WL by 4 is equal to minus WL square by 96. Bending moment C is equal to 5WL by 96 into L by 2 minus half into L by 2 into WL by 4 into 1 by 3 into 1 by 2. Bending moment C is equal to WL cube by 64 EI. This is 3 meter. This can be the uniform distributed load. This is theta is equal to WL cube by 6 EI. Theta is equal to 1 degree approximately equals to 0.01745 radian. Delta is equal to WL raised to 4 by 8 EI is equal to 6 by 8 theta L is equal to 3 by 4 into 0.01745 into 3, which is approximately equals to 0.0392 meter. Here see here, this is 3 meter, this is EI, this is M by I is sigma by Y is equal to E by I, then EI is equal to MR is equal to Newton meter into Newton is equal to Newton, no, Newton meter into millimeter, which is Newton millimeter square. Slope in given beam is equal to shear force at any corresponding section in conjugate beam. Deflection in given beam is equal to bending moment at any corresponding section in conjugate beam. Shear force at A L is equal to 0. Shear force at A right is equal to 0. Shear force at B left is equal to 4.5 by EI. Shear force in conjugate beam, then bending in conjugate beam, bending moment A is equal to 0, bending moment C is equal to 1.5 into 1.5 by EI into 0.75 plus 15 plus 1.5 into 2 by 3 into 1.5. This can be the 2 by 3 part. Then bending moment B is equal to half into 3 into 3 by EI into 2 by 3 into 8. This is 10 kN per meter. This is 3 meter. This is 20 kN. This is 2 into 2 by 3. Then 1 meter. Then 1.5 meter. This is 3 by 4. Then MB is equal to 1 by 3 into 2 into 20 by EI into 2 into 2 by 3 plus 1.